and run. All right, Craig. So we're here to do one of our monthly recording sessions, and you chose as the topic what to do when a project goes sideways. And as my reaction was, no, let's not talk about that.
Right.
But I ended up, you won me over. I mean, it does make sense. And, the reality is there's a lot of research around this. Customers know things can go wrong. Everybody knows that. And that's not really what makes them angry or upset or dissatisfied. What makes them angry, upset, and dissatisfied is how you respond to something going wrong. What is your response? So, I mean, the classic is you just say, hey, there's nothing wrong. It's all on you. And that enrages people. The ideal is you say, you know what, you're right. There is something wrong. And let's see what we can do to correct it. After we talk through this, it sounded like you're in the bucket of, hey, things can go wrong. How do we go about fixing it? So I guess we'll start out with real world experience. You've been with this from both sides. So let's frame it from the two different sides of it that you've been with.
First, just sort of one clarifying comment is that this is about projects where everybody's acting in good faith. Nobody has misrepresented anything. There hasn't been some major change to the project or anything like that. But where, when you start an engineering project, assumptions are made about a lot of different things, and you proceed based on those assumptions. And sometimes those assumptions are right and sometimes they're not. And sometimes even when they're right, you develop something and it just doesn't quite work or look or act the way that people want it. I mean, we're creating new things here. And so there is an inherent risk there that things aren't going to turn out the way that we anticipated they would turn out. And so when that happens, that's really what this discussion is about. It's not about someone who misrepresented something or something like that. This is about engagement on a project, and the project just ends up taking longer. Things that we thought were going to be simpler to implement end up not being as simple to implement, or a process or something that we thought was going to solve a particular need for a project, it ends up not doing it, or there's some other problem with it. And so the scope of the project ends up growing. We have to explore alternative avenues. And the net result of that is that it takes more time than we thought it was going to take. And so we get to that inevitable point in that sort of project where you have to have a little bit of an uncomfortable discussion about something, because we said, well, we think this project will take 500 hours to complete. And now we've exceeded that. Now we're maybe even at 600 hours and it's still not complete. So where do we go from there? So with that in mind, making sure that we frame it around that idea of everybody's coming to this with good faith and wanting to figure out how do we get through this. And to position my approach to this, I come at this from having experienced it from both sides. So prior to starting Embedded Engineering Solutions, I worked for a company and we engaged an outside consultant on a fairly sizable project. This was hundreds of thousands of dollars worth of work and over about an 18-month period of time. And as we got to the end of that project, it started to go sideways. And as a result of the way that was handled, that's part of the origin story for EES, because I decided that there's got to be a better way to do contract engineering. And so here we are. And now, having done this for 14 years, I've had an opportunity to experience the other side of that, the contractor side, where you estimate a project, you work the project, things don't all work out the way that you thought it was going to for a variety of reasons. And you get to a point where now the client is saying, okay, well, we thought this was going to be done in X number of hours. We're now at X plus something, or beyond that, it's still not done. How do we get through this? The approach that I take now is first to recognize.
Actually, before we get into rectifying it, can we touch on a little bit of the root cause? Why does a project end up going sideways? And there's a list of reasons. We made a note of some of them prior to the call, but let's just go through them one. So, of course, there's scope creep, which isn't always bad, but sometimes it occurs. So let's talk about that.
Yeah, so scope creep certainly is an issue. And when sometimes I think there can be a tendency on the side of contractors to say, well, scope creep is 100% on the client. If they say they want a new feature, then that's them and they've got to pay for that. I think the gray area there, or the challenge is that oftentimes clients don't have the same level of technical knowledge that the engineers have. And so they may not even know what options are available out there for something. They might not necessarily know all of the trade-offs associated with something. And so they come with an initial ask for some feature. And then as that gets implemented, or as we start down that path, they realize, no, that's not actually going to solve the problem. That results in scope creep. And I'm sympathetic again to both sides of that. Obviously, coming from the contractor side, we do the work that we're asked to do. But at the same time, I try to be cognizant of the client side and that desire to achieve a certain outcome. And so scope creep is certainly an issue that we encounter and we have to figure out how to manage through. And another one that we talked a little bit about is the long tail of debugging. Oftentimes, a feature gets implemented, but in very complex embedded systems, the debugging aspect of it can dramatically. You start initially and you take care of all of the quote unquote easy things, but then you start to get to things that are intermittent issues, or they only show up under very specialized conditions. And that can lead to long extension in the development work, trying to resolve whatever those bugs are. And it's very difficult to anticipate ahead of time what that might be. You don't always know how things are going to interact together. And frankly, you don't always know what is actually relevant and what is not. Certainly, there are bugs that happen in a system that minimally impact the performance or the user experience. And so those might not necessarily need the same level of attention as something else. That's another place where sometimes projects can extend beyond what the original estimates were. Another one we talked about is security. When we talk about security in embedded systems, it's not a binary, yes, it's secure, no, it's not secure. There are so many layers, and oftentimes clients might start with an understanding of a certain level of security that's necessary, but then once they understand more what the vulnerabilities might be, they might decide, oh no, we really need additional layers. And that's kind of tied to scope creep, but in many ways it's its own thing too. Another area that we talked about is where we're oftentimes we're trying to estimate a large project ahead of time, and you break it down into subtasks and estimate those. And the working assumption underlying that is that each of those is going to be maybe a plus or minus 10 or 20% estimate. And the hope is that a minus 20 on one will balance out with a plus 20 on another. And at the end of it, you end up still roughly at what your estimate was. But it does happen where things just end up skewing into more than what the estimate was, and things drift, and you end up with each of those subtasks just taking longer than you thought they were going to. And all of these really are the things that contribute to a project going over the original estimate.